ओके, तो आप लोगों को एक्सपेक्टेशन पढ़ाया गया है, मैथमेटिकल एक्सपेक्टेशन। हेलो,
यस सर।
मैथमेटिकल एक्सपेक्टेशन पढ़ाया गया है। ओके, सो हम लोग आज डिस्कस करेंगे लिमिट्स ऑफ कोरिलेशन कोफिशिएंट। ओके, so before going to prove this, that limit of correlation coefficient are xy lies between -1 to +1, and both -1 and +1 are included, and -1 indicate perfect negative correlation, and similarly +1 indicate perfect positive correlation. Okay, so and these are the limits. Now we have to prove this how. So there is an inequality known as Cauchy-Schwarz inequality, or you can simply say Schwarz inequality. Inequality, and this inequality says if AI BI I varying from 1 to up to n are real quantities, then okay, then summation of I varying from 1 to n AI BI AI BI whole square is less than summation I varying from 1 to n AI square summation I varying from 1 to n BI square. So this is an inequality, and so if you consider correlation coefficient Rxy, it is simply equal to 1 by n summation of xi minus x bar yi minus y bar. Now, by summation of xi minus x bar whole square 1 by n to the power half and 1 by n summation yi minus y bar whole square to the power half. Now consider consider xi minus x bar is equal to a I and yi minus y bar is equal to bi. Now what you can do, now what you can do, you can write it as ri rx y. Let us denote and this by r, simply r is equal to 1 by n. You can remove this, there is no meaning, you can remove. Now summation of ai bi is equal to summation of ai square to the power half summation of bi square to the power half. Now this r square is equal to summation ai bi divided by summation ai square summation bi square and by Cauchy-Schwarz inequality
सर
it is less than 1.
हेलो सर
हाँ बताइए.
सम स्टूडेंट्स वांट्स टू ज्वाइन सर ज्वाइन कर लीजिए
So in this way this r square is less than equal to 1. So r is obviously minus 1 to plus 1. So this is the limit of correlation coefficient. Okay. Now, and I have already discussed that minus 1 indicates perfect negative correlation, and similarly plus 1 indicates perfect negative correlation. Okay. Now, one important result is correlation coefficient is independent of is independent of change of origin and scale. This is theorem.
ऐसा कुछ चेंज किया नहीं है, बहुत सारे स्टूडेंट ने ज्वाइन करने के लिए ठीक है 20% से लेना है पूरी टेस्ट देना है ठीक है और एमटीएस वाला जो एक्स्ट्रा दे रहे हैं उसकी वजह से होगा 30% मार्क तो आपको
So let us consider u is equal to x minus a by h, and v is equal to y minus b by k. So now what you have, let's wait for a minute. I clear and the board.
जो भी आप नेट करते हैं वो सबका बेनिफिट ले सकते हैं लेकिन न्यूमरी को
Okay. So what we have to prove? We have to prove this theorem that correlation coefficient is independent of change of origin and scale. So what you have to assume, u is equal to x minus a by h, and v is equal to y minus b by k. And what you have to prove, r of xy is equal to r of u comma v. So and how you will do it? So x is equal to, what you have to do, x is equal to uh plus a, and y is equal to bk, oh, sorry, it is vk, vk plus b. Now what you can do, correlation of xy is equal to summation of xi minus x bar yi minus y bar by summation of xi minus x bar whole square and summation of yi minus y bar whole square, and this whole to the power half. Now you can write summation of xi is equal to, so x is uh plus a, so xi will be uh, ui, so your xi will be ui times h plus a, and if it is ui, then its mean will be u bar times h plus minus a, and similarly it will be vi times k plus b minus v bar times k minus b, and the same statement can be written here, summation of ui times h plus a minus u bar times h minus a whole square times, there will also be a summation vi times k plus b minus v bar times k minus b whole square, and this whole to the power half. And now what you can do, you can erase this thing, and you can erase this thing. Similarly, a there will be no effect of a, and square, and it will be nothing but ui minus u bar, vi minus v bar, and again here also you can take summation h square outside, and it will be ui minus u bar whole square, sorry, it will be square minus vi minus v bar square to the power half, whole to the power half, and this you can cut this, and this is nothing but correlation of u comma v. Thus we have proved that correlation of x and y is equal to correlation of u comma v. So what we have done, we have changed the origin of x by a and scale by h. Similarly, we have changed the origin of y by b and scale by k. And we can see there is no effect of the changes on the overall correlation coefficient of x and y. So correlation, thus we can say that correlation coefficient is independent of correlation coefficient is independent of change of origin and scale. Okay, so next, and there is a result. Two independent variables are uncorrelated. Two independent variable are uncorrelated. If so, but converse is not true. Converse is not true. So if two variables are independent, then covariance of xy will be 0.
वो इंडिपेंडेंट वेरिएबल आर है कि और हो?
Two independent variable r, it is r, sorry, it is r, uncorrelated, but converse is not true. If x and y are independent, so now what we can see the correlation of, so correlation of x comma y is equal to covariance of xy by variance x, variance y to the power half, and this is 0, and so the overall correlation will be, so it will be 0 if two variable, but converse is not true, means if correlation is 0, we cannot say that two variables are independent. So we will prove this with help of an example. Okay, so what you can see, x is equal to minus 3, minus 2, minus 1, 1, 2, 3, and y is 9, 4, 1, 1, 4, 9. So the relationship between y and x is y is equal to x square. And what is xy? You can say minus 27, minus 8, and minus 1, 1, 8, 2, 7. So what will be rxy? Obviously, this x bar is 0, and y bar is 28 by 6. So x bar is 0, and summation of covariance of xy is equal to 1 by n summation of xy minus x bar y bar, and you can check it, it will be 0, and your correlation will be, which implies correlation of x and y is equal to 0. But you can see these are related, y is equal to x square, but the correlation is 0. Okay, so and in the above example, x, y are uncorrelated, but there is a they are connected by a relation, y is equal to x square. Thus we can see that x, y are uncorrelated, but they are connected by equation y is equal to x square. So, next I'll discuss rank correlation. Okay, so I'm writing some example. You have to complete this example. Okay, your homework problem. The variable x and y are connected by the equation ax plus by plus c is equal to 0, so that correlation between them is correlation between them is -1 if the sign, if the A and B are sorry A and B are alike and minus 1 plus 1 if they are different. So you have to prove this. Okay. Fraction. Next, I'll consider rank correlation coefficient. So next thing is standard error of correlation coefficient. After we'll start rank correlation. So standard error of correlation coefficient is equal to 1 minus r square by under root n, and probable error of correlation coefficient is, so these are empirical results and I'll not go to proof of this result. 1 minus r square by n. Okay. So what is probable error of correlation coefficient? So the probable error of correlation coefficient, the error of correlation coefficient is an amount which is added to which is added to and subtracted from and subtracted from the mean correlation coefficient, from the mean correlation coefficient produces amount which produces amounts within which the chances are are even that a coefficient of correlation from series selected a correlation coefficient from which from which a series selected at random will fall. Okay. If R is less than, correlation coefficient is less than probable error or R, correlation is not significant. Next is, if R is greater than P, probable error of R, correlation coefficient is definitely significant. Okay, so this is basically significance for significance of correlation coefficient. Next correlation is, other type of correlation is rank correlation. Rank correlation. Okay, so what is rank correlation? So if we consider the relationship between beauty and intelligence, so there is an example. Beauty and intelligence. So these quantity are not measurable. Means you cannot measure in some unit. Okay. However, you can rank it. Okay. So in this case, correlation coefficient. In this case, correlation coefficient between. So suppose you have two rank, beauty and intelligence, rank by individual individual A and rank by individual rank by individual to beauty. It is denoted by A. To beauty. And then rank by individual to intelligence, and this is denoted by B. Okay, so this is rank by you can consider ith individual, and this is this is denoted by, suppose it takes value xi, and it takes value yi. And what you have to do, you have to calculate correlation between A and B. Suppose A is beauty and B is intelligence. So it will be correlation between xi and yi. Obviously, rank will be given in terms of 1, 2, up to n. And similarly, y will also give rank up to n. So x bar and y bar will be your mean, and it will be x bar is equal to y bar will be n into n plus 1 by 2 divided by n, and it will be n plus 1 by 2. Okay. And similarly, variance you can calculate. Similarly, you can calculate sigma x square is equal to sigma y square. It will be n square minus 1 by 12. Now, if you calculate this rank, you will get the formula 1 minus summation of di square divided by 2 times n into sigma x square, and where di square is equal to xi minus yi, means rank difference between two ranks. And what you will get, this 1 minus summation di square divided by 2n di square n into n square minus 1. So you can, if you calculate the correlation between x and y, you will get this result. Okay. So di square is the difference between two ranks. Di is equal to xi minus yi. Okay. So this is the formula of rank correlation. Okay. So this was all about correlation coefficient. And one more thing, and you should go through it by yourself, and that is tied rank. Okay. In rank correlation coefficient, go through the tied rank. Okay. Tied ranks. What are tied ranks? Go through it. Okay. And in next class, I'll discuss regression. Okay. After that, we will discuss some statistical models and multiple and partial correlation. Okay. Is there any doubt? कोई डाउट है किसी को? ओके, तो कल एक और क्लास लेंगे, ठीक है? और प्रोबेबली इसी टाइम लेंगे. ओके.
सर कब तक क्लास चलेगी?
देखिए, कोशिश करूंगा कि कल कंप्लीट हो जाए, नहीं तो फिर एक और क्लास हो सकती है.
ओके सर, थैंक यू. ओके सर, थैंक यू सर.
थैंक यू सर.
Gracias.